I'm Rory.
I'm Zoe.
And I'm Josh.
We are part of Team 359A.
We will be explaining the intricate details of how math is incorporated into our Gyro Sensor program by asking questions. We want people to understand the steps in order for the gyro to work and why the gyro sensor is important.
A gyro sensor measures the turn rate and calculates the direction of a robot.
We use the gyro sensor when we want the robot to center itself and when we want the robot to H-drive while correcting itself. Overall, the gyro sensor corrects our robot so that we can have more accurate results in our autonomous.
The gyro sensor works by first finding the error that the robot makes per millisecond. Then the gyro will turn the correction and correct itself.
Before the gyro sensor, our robot was a lot harder to program, especially with omni-wheels. Our robot would always drift off to the side, which was a big problem because the autonomous requires a lot of accuracy. And because our robot drifted, it was never accurate.
When we added in the gyro sensor, our robot stopped drifting. What the gyro sensor did was that it found the error per millisecond, then it calculated the correction, and then it corrected itself.
We ran into a big problem while programming our gyro sensor function. While the gyro sensor corrects itself, the robot will move left and right. We thought that if we increase the number of degrees, the robot will turn while correcting itself, and also increase the speed that it turns. Then the robot will correct itself much faster, from 10 degrees 90 speed to 15 degrees 100 speed. But actually the robot took much longer because it would skip over correct value and it would just keep turning left and right, not continuing on in the program.
Instead of increasing those values, we decreased them, from 15 degrees at 100 speed to 5 degrees at 80 speed. That helped out a lot with shortening up the amount of time the robot took to correct itself. Step 1. Find drift. In other words, gyro error. At 5 seconds, we're going to read the gyro. Anything we read is drift because it's not moving. In our case, we read 3 degrees, error. But to make the numbers easier to understand, we'll use 5 degrees. The gyro error is 5 degrees divided by 5 seconds, which is equal to 1. 1 is our gyro error. Step 2. Correcting for drift. We added a touch LED this time, so it starts off red and then turns green after 5 seconds. While it's red, it's calculating step 1. It's finding gyro error. After 5 seconds, the LED is green and we have calculated gyro error. Now we have to solve for gyro correction. To solve for gyro correction, you take gyro error and multiply it by the time that has passed so far. All these steps work towards finding gyro value. Gyro value is the value that we get after adjusting for drift. We find gyro value by subtracting gyro correction from the gyro sensor.
There are many advantages to the gyro sensor, such as how it helps with getting the robot to its exact destination, as well as that it helps with the robot being straighter and more accurate.
But there are also some disadvantages to the gyro sensor, such as how difficult it is to program and find precise values for the gyro sensor. It also takes long for the gyro sensor to calculate the correction.
With speed measurements, computing movement degrees, and using programming functions to condense our code, our gyro sensor is a vital part of our robot's autonomous program.